Geometry lesson 87. It's about circles, circle geometry grade 11, so that you've got to be able to identify your 9 theorems. But remember, it's not just the 9 theorems, it's also some of the angles of a triangle, parallel lines, everything that you've already done in your life can still be practical here. So when we start off in the sum, what's something that springs to mind? The parallel lines will mean what for me? Because now you've also got to realize I told you that this was 2x. 01 was 2x. So in other words, this is going to be one of those geometry sums that's always going to be in terms of x. You're not going to have 20 degrees or something. You might, but at the moment it looks like everything's going to be in terms of x. So I've got the 2x there. What is that 2x? Angle at the center. And that should be twice the angle at the circumference. First question was find F1. I didn't put it in with this F1. I'm the correct one. Okay? So F1, to find that, angle at the center twice the angle at the circumference. There's various ways that can appear. The easier one is when you look at it like this and see it going to the center and going to the circumference. Where's the circumference one? E and A. E and as well as A. Do you see it?
Yes, ma'am.
So meaning that if this is 2x, then that will be 1x and 1x. And that's why you take your color pen to know everything that you found out. But more than that, you can also use this angle at the center to find that angle at the circumference. Because that's the squished out one. The one that says, whatever that is double than this one. So if this is 8, then that is 2a. So it looks like that, but the mistake you could have made is to say, if this is 2x, then this is 1x, and it's not.
Yeah.
Are you with me?
Yes, ma'am.
If you wanted to use that, you'd have to find that angle there on the outside, the reflex angle, which would have been 360 minus 2x. And half of that for angle at the center twice the angle circumference is 180 minus x. But there's another way that's a little bit actually more logical or straightforward. Meaning what? Of a cyclic quad. Because CEVF is a cyclic quad. So if I have this x, I can find that one. Now you didn't have to do it, because both of those ways would be correct. Saying that this is 360 minus 2x, your reason? Revolution. And then saying that this is 180 minus x, because angle at the center is twice the angle at the circumference. What you and I did is, we started off and said, whichever one, doesn't matter, angle A is equal to x, and the reason is what?
Angle at the center equals 2 times the angle at the circumference.
Okay, now whether you used A or whether you used E, doesn't matter. But basically they're both going to be. And eventually I'm going to use that as well. So I could just as well put it in here. You're not a parrot, you don't have to do it precisely the way I've done it. But you could have just as well said that's also equal to E, then I've done it. Then I've said everything that I found out on my sketch. Are you with me?
Yes, ma'am.
Do you have to do it this way?
No.
Okay, but now I've done it, so when I need it, I've done it already. And then that means that F1 would be 180 minus
X.
Reason?
Opposite angles of
Opposite angles of a cyclic quad. Now you don't have to tell me which one, because basically you could have used any one. Normally I say here cyclic quad ACFB, because they are also supplementary, because opposite angles are supplementary. And that's the reason, and most of you say opposite angles of a cyclic quad are supplementary, but then often you say supplementary here, but you say they're both x, meaning you know that they're both the same, and that's not true. They've got to be supplementary. Have I done the question? They asked me for F1, I've done it, and I think this would be worth about 3 marks. What's their mark allocation there? 4 marks. So it would have been for the angle at the center, and then for opposite angles of a cyclic quad to make it up 4. If you had used the other one with the revolution, you would have adjusted the marks there, but you can't get more than 4 marks. Or less. If you've done a little bit less work, but all the steps are there, it's fine. Okay, second part. Prove to me that DF is equal to BD. What's your inclination? How would I prove that those two lines are equal?
Use the parallel.
Isosceles triangle. Are you with me? That should be your inclination. I'm in a triangle, and to find that those two sides are equal should mean that B1 and F2 should be equal, but you got to prove it. Now, what would F2 be? How come?
Because of angles on a straight line.
Because it's a straight line or exterior angle of a cyclic quad. There's so many ways, and the rules all apply, and they fill into each other. Are you seeing it?
Yes, ma'am.
Exterior angle of a cyclic quad, and then B1?
It's the corresponding.
Parallel lines will also be X because of those two corresponding angles. Or B1A, exterior angle of a cyclic quad. Are you seeing it? If you haven't seen it and you see something now, that's good. That's good. If you just saw the corresponding angles and that was it, it's fine because you've done it. So B1 is equal to E because of corresponding angles. Enough? No, if you use corresponding angles, alternate angles co-interior, you've got to say EC
Parallel to BF.
Otherwise nothing. Alright? So I know that B is X. How come F2 was X?
Because
Angles on a straight line. And therefore, it is true that that is going to be the answer, but don't you first want to tell me, can you see that F2 and B1 are the same? Because I've done it. I've proven it. So if you want to say already proven, or if you don't want to say anything, it's fine. I can see it here. But that means the two lines are going to be equal. Namely, BF and B. My reason.
Sides opposite equal.
Excellent. Sides opposite equal. Angles. Definite difference. Angles opposite equal sides. Sides opposite equal angles. I know the angles, so that's why the sides opposite to the equal angles are equal to each other. How many marks? 4 again. So let's see how we would have applied this. Definitely for this last one, a mark. Proving that as such, maybe not a mark, but to get to them. So the corresponding angles, and since this was the easiest one, I think I would have given 1 mark. Including the answer as well as the reason 1 mark. So no reason, no mark. And then maybe I think they would have given 2 over there. The implication is there that the angles are equal to each other. Write too much rather than too little. And that's why the angle sides opposite to those equal angles are equal. Let's go to C1 equal to C3. So they're trying to prove those two must be equal to something. We're inclined to think it's going to have something to do with X again, right? So now we're going to start searching. Can we not maybe, let's throw a few things around. Can we not maybe say that C1 is the exterior angle of a cyclic quad?
No.
Why not?
It's not extended.
Okay, so if this is a cyclic quad, to have an exterior angle, one of those lines should have been extended, and that's not. I'm just showing you stuff that might be a mistake.
Yes,
Okay, so C3, maybe bow tie. No, this is not a bow tie. Are you hearing what I'm trying to show you?
Yes,
Let's check what's going on here. So we're trying some more. Who has an idea? You can speak to me here. Corresponding angles with what?
F2.
F2. 2 as well as 3. I like that. Do you see it?
Yes.
The parallel lines with X there. Then this whole thing should be X. Okay, does it help me at all? So at least I know some of it.
Yeah.
And what else? Okay, so now we're stuck because we never did what I should tell you always to do at the start. Go through all of your theorems. Theorem 1, and line from the center perpendicular to a chord. Maybe an odd chance that it could happen here, but I don't know that it's 90 and I don't know that it's bisected. Are you with me?
Yes, ma'am.
Angle at the center was definitely there, we've already done it. Then semicircle, there is no center, but there's no Is there a diameter? There is a diameter, and they actually said AB is a diameter. But it doesn't help me for a semicircle because it didn't finish up. Then we've got number 4, the bow tie.
But
Do you see the bow tie?
Yes.
Whether you've used it or not, because we didn't say why they were both X was because of bow tie. We said because of the angle at the center twice the angle at the circumference. But you see it being a bow tie. And
C1 and B3.
C1 and B3. Okay, so let's make it a dot. Dot UD. Dot UD. But now I'd like to make it all in terms of
X.
X if possible. But is there a possibility to also make that X? Isn't there maybe a cyclic quad going here? Say no. Because it's not shown on the circle's edge. If I can prove it as a cyclic quad, I can use it using one of my 3 reasons. So I'm struggling. I'm trying to know, I know that they are equal, but I'd like to put it, and now please don't go. If that is X, then maybe make this Y. That's fine, and Y. But please don't use the whole alphabet in one sum. If you do this, I'm trying to get you to the step that you're saying, I know that they're equal, but I can't get them in terms of each other, in terms of X in some sort of a way. Then you're allowed to do what we've just done here. So this is a higher level geometry sum that you have to go and do. So I couldn't get there. So can I now use something like Y? Okay? But with restraint. Don't go the next one is Z and the next one is A and the next one is all the alphabet letters. Then you're going nowhere. I didn't have another choice here because I'm not seeing something else that is related to each other.
Ma'am, I see B1 equals to C.
B1 equal to?
The whole C.
That's it. So it's still equal to?
X.
X.
Okay.
Are you happy?
Yes.
So why did we say that that was X?
Because of corresponding
Because
angles.
of corresponding angles. But just as well as, like you said, that's the exterior angle of a cyclic.
Quad.
Why? Because it is a cyclic.
Quad.
Quad. But mainly, it's still X.
X.
But these two being equal, do you agree with me that that is
The bow
the bow tie?
and also the
Okay, and I didn't know what to call it, so I'm calling them Y. And how does that help me? Okay, now also the Y, yes, okay, that's one's right. What else can I do to find this little piecey here? Because I need to know what this is. I need something to help me. Any ideas? How much would this, for instance, be? This one here. Minus. Okay, now tell me, what did I teach you in trig? To always write 180 minus in a bracket. Do you think that's necessary? Yeah. Where are we? We're in geometry. So maybe not necessary, but if you want to stick to it, it's fine. But for this time, it's not going to make a difference because we're not busy with sin, cos, and tan. But we're going to do a poof reduction formula, okay? Does that make sense, what I've just done there?
Yes, ma'am.
Okay, but I still don't see the answer here. I know that this whole thing was X. What else? What else? Because I'm putting stuff there that I'm not going to use. It's not going to help me. You have to see something else, okay? Let's go on. Cyclic quad we've done. Opposite interior angles, exterior angle even we could have done. Then theorem 7, 8 and 9.
There's no tangent.
There's no tangent, so don't even look for it. Then what else? The parallel lines. Looked at it. But something to take note of always in a circle is what? The radii are always equal, making a possibility for what?
For isosceles.
Isosceles.
Triangle.
Triangles. And isosceles triangles
Angles.
makes the angles the same.
Yes.
Which angle?
A.
1 and 2 is equal to X. So what does that make this thing here? If the whole thing is X and this PC here is Y, then this is? Which one minus which one? Decide. The bigger one minus the smaller one is going to be X minus 1. Now, how's that helping me? What am I trying to find out? If this one is X minus Y, then what would this thing be? Just y. And if this is x minus y, the PC, and this is x,
That's
what's
just
this?
one.
Just y. And C1 and C3 are the same. By no means is this a level 1 sum. Okay, let's go through it again, because now we've got to write it. We've actually solved it, but it doesn't feel like it. Okay, so let's go through it again. Did I use this? Not at all, but is it true? Yes. So if you write it down and give reasons that it's a straight line, good for you. I'm not giving you a mark because it's not taking you anywhere. Okay. What did we say that made sense? We know that the whole of C2 and 3 is x. Did we say it yet? So what are we going to say? C3 plus C3 equals x, which was equal to B1, according to one of you guys. That was exterior angle of a cyclic. What? Or it could have been corresponding angles. You don't have to give alternates. And then what else did we say?
You said that
B1
C1 equals to B3.
C1. But okay, now I called it y. So what do you think would be a good idea?
Let's
Let, what did I say? C1 equals to y. So C1 and 2 would be equal to, oh, no, I'm getting ahead of myself, sorry. So C1 would be equal to B3, right?
Yes.
Is it really necessary that I said that though? Not really. I'm just trying to figure out, do I need to write it down here? Was it crucial for me to know that that was y?
No.
Did it help me at the end?
Did not.
I just wanted something that I can then say, the whole thing is x, and this small thing is y, that the little PC there is x minus y, and if this PC is x minus y, the big thing is x, then this will only be y again, so that I can get to both of them as y. So did I use this? Is it true that they are equal because of
Circles in the same circle.
angles in the same circle segment, the bow tie? It's true, but I'm not using it, so I don't have to write it.
Okay.
If you do write it, is it a problem?
No, it's not.
Okay? It's not just how it's taking you anywhere else. So then C1 was y. So C1 and 2 together is equal to what?
X.
Which was equal to angle. It always helps the marker to see where you made your connections. It's not necessary that that angle there should be there, but it helps the marker to see where you made your connection. Why is that though equal to each other?
Angles opposite.
Angles opposite equal sides? Is that enough?
No, we have to say radii.
You've got to say the radii, because both of those things bring me to this reasoning. You've got to say angles opposite equal sides, different from this one, right? Because now you have the sides are equal, and the sides are equal because
Radii.
radii are equal. Whether you switch this around doesn't matter, but both of them brought you to that connection, that should be equal to x, the whole thing. And that says, therefore, that C2 is equal to x minus y. What's my reason? Logic. If the whole thing is x, the small piece is y, then what's left is x minus y. Make sure it's not the other way around. And then we can say, and therefore, C3 would be equal to,
C1.
well, we've got to say first that it was equal to x, right? Y. Again, y. Logic, because I've got the y and I've got the x minus y, so therefore that PC there should be just y. So therefore, again, no reason. Why is C1 then equal to C3? Proven if you want. Just leave it like that. Because I can see out of what you've written to me that you've got the big piece, the smaller piece, the big piece, the smaller piece. When you subtract them from each other, that's how you get to the answer. So the main thing here was, I know the big one is y, the small one is x. No, I said it the other way around. The big one is x, the small one is y, then there should be x minus y. But if this then is a big x, x minus y, then that should be y again. And it helps you if it's in terms of something else. You could have done this without having the x's and y's, but then you've got to explain so much more if it's not in terms of x and y. Okay?
Yes, ma'am.
Last piece of the question said, find me the area of triangle BFD. Let's make it blue here. Oh, it's green, sorry. This green triangle here, and triangle AOC, meaning I've got this triangle over here. Let's make it blue. And I want to have the area in ratio to the area. So something like 2 to 1 or 3 to 2 or whatever the case may be. Are you with me what the question is? But you have to go get the area of a triangle. Toolbox, area of a triangle. Half? Yes. But first of all, half base times perpendicular height. So we're going to work here. No, because I don't have a perpendicular height. Then what you were just saying now, for area of a triangle, you can also use the area rules where you need two sides and the included angle. Now let's have a look at this one first. BFD. I've got 5 centimeters given to me now by the question paper. Meaning, that should also be 5. So do I have 2 sides? Because I don't have this one. Oopsie, but now I don't have the included angle, or do I? What will this be? Because you don't have the x's. But if that is x and that is x, this will also be 180 minus 2x. So to find the area of triangle BFD, it would be area rule, A, B, C, and C, and not like you sometimes write cos. 2 sides,
It's 5 and 5.
it's 5 and 5. But the included angle H is not something I can work with, is it? Oh, it is a reduction formula, by the way. Yes, it is. But I don't have it. I can't put it into a calculator to say that this answer is 25 or 66 or whatever. So it looks like a little bit of a problem. So let me just go to the other one for the moment and look at area triangle AOC. In AOC, we've got a similar situation once you now know from the previous question that those sides were equal. So it builds up and it's still difficult. But if that's then 6, then this will also be 6. And the angle in between is again 180 minus 2x. Remember the whole angle was x. The bigger your sketch, the more you can see what's going on there with all the x's. So make sure you write clearly for yourself. This would be 180 minus 2x again. So for my area rule, it would be half of the 2 sides. The included angle is again 180 minus 2x. Again, I'm not going to be able to work it out. But what did they ask me for? The ratio. And when I've got a ratio, and here's sin and sin, same. You just leave it away.
Oh.
It's like when I have 10 to 5. How does this become 2 to 1? Because you're dividing by a common thing. Basically, that's what's going to happen here. Just on a higher level of sum. So whenever there's a ratio, you simplify. You're going to simplify because it is the same thing. You're going to simplify by cancelling it out. You see where we're going?
Yes.
So yes, you can go say that this is sin 2x. Excellent. Because of a reduction formula. It's true. And the same thing's going to happen here. But it's not actually necessary if I know where I'm aiming towards. But it was difficult. What's this answer then going to be? 12,5. That's perfect. Can you leave it 25 over 2 for the moment? This would be the 2 sides with 6. So 36 divided by 2 is 18. So it's 18. We'll just write it a little bit smaller. 18 sin 2x. And this will be 25 over 2. So basically what happens is, now technical stuff, because I'm not quite finished. You're actually finished but not quite. Grade 8, 9, and I know COVID has done a number on lots of us. So maybe you didn't really study this very hard or taught this very intensely, but in ratios, this is not acceptable. You should never, because a ratio is actually also a fraction. Do you realize that?
Yes.
3 to 4 actually means 3 over 4. Okay? So you shouldn't have a fraction over a fraction ever. So when you are writing ratios, this shouldn't be a fraction inside of the fraction. How would I simplify that? What can you do?
Divided by
It's like an equation. It's not an equation, but you treat it as one, because if you time both sides with 2, then you're going to have the simplest form of a ratio. So a few things to remember. Never have fractions inside of it, and that means something like 2, 1, 2, 3 should also not happen. You'll rather like 21 to 30. You shouldn't have ratios inside of the ratio you're having a fraction, which is either decimal or normal fraction, just beside the point. But did you follow this up to here? All right.